everyone, I'm going to go through some revision for you for your P4 test. So, just going to begin now. We're going to look at, initially looking at a series circuit with a 12 volt power supply. Going to have an ammeter in here measuring 3 amps and a resistor with a resistance 3 ohms and another resistor of unknown value, and that completes the circuit. What I'd like to find out is the total resistance. Now I'm going to use Ohm's law, his equation, VIR, so VIR, potential difference, current, resistance. Now I want to find resistance, so I'm going to do the potential difference divided by the current. Now I want the total resistance, so I need to do the total potential difference divided by the total current. Now the total potential difference is from the power supply here, so that's 12 volts, and the total current is in the ammeter, so that's 3 amps. So 12 divided by 3 is 4. So I know my total resistance is 4 ohms. So if I wanted to figure out the value of this one, I would know that my total is 4, the first one is 3, so that must make this one 1 ohm. Okay? Next you need to have a revision of the circuit symbols. So we'll just have a quick look at the main ones you need to know. So this is a cell, has 1.5 volts. This is a battery, which is more than one cell and can have any voltage you like or potential difference. This is a filament lamp or a bulb. Next we've got an ammeter which measures current, and a voltmeter which measures potential difference. And you also need to know a switch. We also have some other components. So this is a resistor. We have some things that look like resistors. That is a thermistor, which is a resistor that depends on temperature. And this is an LDR, a light dependent resistor. The 2 arrows here on the symbol mean the light is shining on the resistor. So the resistance of an LDR depends on light intensity. This is a diode which only lets electricity flow in this direction. It stops it in this direction. This is a type of diode called an LED, which means a light emitting diode. So you draw arrows coming out to show the light coming out. The other one you need to know, it looks like a resistor but it's got a line through it, is a fuse. Okay, so pause the video, make sure you've learnt those. Next we're going to have a little go at a slightly more challenging circuit than the last one. I've started to draw it here. So I'm going to use a 20 volt power supply, okay, and it's measuring 0.5 amps here. And I'm going to put some resistors in the circuit. So I've got 3 resistors, they're all in series, okay, and I'm going to put a voltmeter across each one. So I've got V1, V2 and V3. So they're going to measure the potential difference across each resistor. I'm also going to put a weird switch in here, and we'll talk about what this switch does later. Now I know the resistance of this resistor is 20 ohms and the resistance of this resistor is 10 ohms. I don't know the resistance of this one, but I'm going to figure it out. And I'm going to use Ohm's law to do so. So V equals IR. So what I'd like to do is it would be, I'm going to figure out the voltage across these two resistors, so V1 and V3, because I know the total's 20, so if I figure out what V1 and V3 are, I could then figure out number 2. So, V1 will equal the current times the resistance, I times R. So the current is 0.5, and my resistance of V1 is 10 ohms. So 0.5 times 10 gives me 5 volts. I'm going to look at V3 next. Again, voltage is I times R. So my current is still 0.5, it's a series circuit, the current is the same everywhere. My resistance this time is 20. So 0.5 times 20 is 10 volts. Now, I know my total voltage is 20 volts. I know this one, V1 is getting 5. And I know this one, V3, is getting 10. So I need to figure out how much is left for this one, V2. So what I'm going to do for V2, I'm going to say, right, well, I've got 20 volts total. I'm going to take away this 5, and I'm going to take away this 10. And that leaves me with 5 volts. So I know the voltage of V2 is 5 volts, adding up to 20. That will then allow me to work out its resistance. So the resistance is going to be potential difference divided by the current. So I found my potential difference, it was 5, divided by my current, which is here 0.5. So that makes my resistance 10 ohms. And that's easy to check because this was getting 5 volts and it's 10 ohms, but this one also gets 5 volts and its resistance was 10 ohms. So we know the resistance of them is the same. Okay? Quite a difficult circuit that, but we've managed to use the equation appropriately. Now another equation you have to remember is Q equals IT. Here's the triangle. Quit. Q is charge, it's measured in coulombs. I is current, it's measured in amps. And T is time, and it's measured in seconds. So we're going to use this equation to work out the charge. I'm going to say, right, well, the current is 3 amps and the time is 60 seconds. So what would the charge be? Well, Q equals I times T. So I is 3, T is 60. 3 times 60 is 180 coulombs. And that would be my answer. So you could pause the video and perhaps give yourself some other examples to do there. Right. Oh, I forgot. I need to go back to this. I've got this pesky switch here. What would happen if I close that switch? Well, let's have a look. I've closed the switch. I've got a resistor here of 10 ohms. Now, let's imagine the current is this peachy colour. Current's going around here, happy, 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 happy. Right, I'm going to go through this resistor, give it some of my energy. Oh, I've come to a junction. That's now made a parallel circuit, and the current will go the quickest way. So actually, what happens is the current will all go this way, because it won't want to go through the resistor, that's too much hard work. So instead it will go this way. Now, when it goes that way, it's missed that resistance out. So in our first circuit, the total resistance, so the first time we did it, the total resistance was 10 plus 10 plus 20, which equals 40 ohms. But when we close that switch, the current will ignore that resistor, so now it only has to go through the 10 and the 21. So the current, the resistance is now 30 ohms. So the resistance has gone down. So the effect of adding a switch here and closing it reduces the resistance, which would in turn increase the current. Okay? Right. Just like to quickly look at these graphs of voltage against current for, you need to know these off by heart, a resistor, a bulb and a diode. And we did require practical on this. So the one for the resistor looks like this. You need to know these off by heart. The one for a bulb looks like, oh, I've done it wrong. This one's the resistor. I got excited. This one's the bulb. I'll make this one the resistor. So the resistor is a straight line and it follows Ohm's law, which means it's a straight line. And a diode has this, no current until you're on the positive side of the voltage, and then the current increases. So we need to talk about why a bulb looks this way, section 1 and section 2. We've done this before, you did it on a worksheet so you can have a look at it. But in section 1, as the potential difference here increases, the current increases. Okay, so here's your current here, so the line's going up. Okay, the wire heats up. As the wire heats up, temperature increases. This makes it more and more difficult for the current to flow, so that means the resistance is increasing. If the resistance increases, what happens then in section 2 is the current will start to level off to a maximum value. So this description here would answer the question as to why this potential difference current graph for a bulb looks this way. As the potential difference increases, the current increases. As the current increases, the wire heats up, which increases the temperature, makes it harder for the current to flow when it's hot, so the resistance increases, and then the current levels off at a maximum value, which is there. Okay? Right, the very last bit we need to revise is just quickly about static electricity. So what you need to remember is, let's say you've got some sort of material here and you've got some sort of material here, but they're both insulators, so not metals. And you rub them together backwards and forwards. So remember, the force we're going to use is friction. You need to remember what transfers. Now, the particle which transfers from one material to the other is electrons. So when you rub these two together, the friction causes electrons to move from one material to the other. So the extra electrons have gone onto this material, and remember they're negative. And that has left this material here with an overall positive charge. So what we need to be describing with static electricity is friction causes the movement of negative electrons. Okay? So friction causes the movement of negative electrons. That causes this material here to become negative, and because the electrons went from here to here, that leaves this one being positive, and they will now attract each other. And you also need to just remember that the electric field of a negative electron looks like the spokes of a bicycle. So if you put a positive charge here, the arrows go in because it would be attracted towards the negative electron. Right, so hopefully all of that should really help you with your test. Watch it a few times, make some notes. Okay, make sure you understand it, go back over your notes from the lesson. And yeah, good luck.